Hello, welcome back. Today we're going to do a minimum spanning tree problem. This question is actually a LeetCode premium question, but you can do this in LeetCode. I left the link to this question in the description below. There are n cities in this question, and their numbers range from 1 to n. We are also given a set of connections. The connection is a set of arrays. The first item and the second item represents the nodes of each edge. And the third item is the weight of the edge. In the example they provided, 1, 2, 1 means there's an edge between node 1 and node 2, and it has a weight of 1. Here is a representation of the graph in one of the examples they provided. There are 3 nodes and 3 edges. Our job is to determine what's the minimum cost to connect the 3 nodes, the 3 cities. And if all the cities cannot be connected, then we will return -1. Essentially, this question is asking us for a minimum spanning tree. For this graph, the minimum spanning tree is here. As you can see, the total weight of this tree is 3. So that's the output that we want to return. Today, we will use Kruskal's algorithm to solve this question. If you are new to Kruskal's algorithm, I have a long discussion on this in part 3 of this series. The link to that video is in the description below. This Java code is provided in the GitHub links below. Kruskal's algorithm involves using the union find structure. I also have a video where I discuss union find, and the link to that video is also provided below. So if you're new to union find or new to Kruskal's algorithm, please check out those 2 videos I mentioned before continue with this one. To start off, I will use some of the boilerplate codes for union find. So I will have the find parents function and also the union function. In addition, I will have the parents array, and I will use a for loop to initiate the parents of each node to be itself. I will also initiate 2 data structures. One is a priority queue or the heap, where I will store all the edges or all the connections. The other one is a half set, where I will store all the nodes that are currently in the existing minimum spanning tree. I will also initiate the total variable in which I collect the accumulation of weights of the minimum spanning tree. First, I will add all the connections to the heap. So for this particular graph, there will be 3 arrays, 1, 2, 1, 2, 3, 2, and 1, 3, 3. For these arrays, the last value is the weight. The heap sorts all the connections by weight in ascending order. So the first item on the top of the heap is 1, 2, 1. First, I will dequeue 1, 2, 1. Now the minimum spanning tree will have the 1 and 2 edge. I will add 1 and 2 to the visited node set. And also, I will update the total value by 1. That is the weight of this edge. Each time we add a new edge to the existing MST, we always check whether there's a cycle in the tree. So this is what this line is for, to see if one of the nodes has the same parents as the other. And if that is not the case, we will perform a union operation. Basically, we are saying that these nodes are now together in the same disjoint set. This is the operations I was referring to when I say I add the nodes to the minimum spanning tree. Next, I will dequeue 2, 3, 2, and I will add the edge 2, 3 to the existing MST, and I will add 2 and 3 to the visited set. In addition, I will add the edge weight, which is 2 here, to the total value. So the total value now is 3. And the next item on the heap is 1, 3, 3. So that is the one I will dequeue. I find that 1, 2, and 3 nodes are already visited. So I will not do anything here. Now the heap is empty, and this will exit the while loop. Now we will check whether the visited set has all the nodes in the graph. If it doesn't, that means we have exhausted all the connections, and we are still not able to connect all the cities. So in this case, we will return -1. But if we have visited all the cities, the total value is what we want to return. So in this case, it is 3. Okay, now let's take a look if this works. And it looks good. That's it for today. If you have any questions, please leave a comment below. Hope to see you next time.